Scientific criticisms are a body of analysis of scientific methodologies, philosophies, and possible negative roles media and politics play in scientific research. Criticism of science is distinct from the academic positions of anti-science or anti-intellectualism, which seek to reject entirely the scientific method. Rather, criticism is made to address and refine problems within the sciences in order to improve science as a whole, and its role in society. Philosophical critiques. Philosopher of science Paul Feyerabend advanced the idea of epistemological anarchism, which holds that there are no useful and exception-free methodological rules governing the progress of science or the growth of knowledge, and that the idea that science can or should operate according to universal and fixed rules is unrealistic, pernicious and detrimental to science itself. Feyerabend advocates a democratic society where science is treated as an equal to other ideologies or social institutions such as religion and education, or magic and mythology, and considers the dominance of science in society authoritarian and unjustified. He also contended that the demarcation problem of distinguishing science from pseudoscience on objective grounds is not possible and thus fatal to the notion of science running according to fixed, universal rules. Feyerabend also criticized science for not having evidence for its own philosophical precepts, particularly the notion of uniformity of law and the uniformity of process across time and space. As noted by Stephen Jay Gould, we have to realize that a unified theory of the physical world simply does not exist, says Feyerabend. We have theories that work in restricted regions. We have purely formal attempts to condense them into a single formula. We have lots of unfounded claims, phenomena that do not fit into the accepted framework as suppressed in physics, which many scientists regard as the one really basic science. We have now at least 3 different points of view, without a promise of conceptual unification. In other words, science is begging the question when it presupposes that there is a universal truth with no proof thereof. Historian Jacques Bazoun termed science a faith as fanatical as any in history, and warned against the use of scientific thought to suppress considerations of meaning as integral to human existence. Sociologist Stanley Aronowitz scrutinizes science for operating with the presumption that the only acceptable criticisms of science are those conducted within the methodological framework that science has set up for itself. That science insists that only those who have been inducted into its community, through means of training and credentials, are qualified to make these criticisms. Aronowitz also alleges that while scientists consider it absurd that fundamentalist Christianity uses biblical references to bolster their claim that the Bible is true, scientists pull the same tactic by using the tools of science to settle disputes concerning its own validity. Philosopher of religion Alan Watts criticized science for operating under a materialist model of the world that he posited is simply a modified version of the Abrahamic worldview, that the universe is constructed and maintained by a lawmaker. Watts asserts that during the rise of secularism through the 18th to 20th century, when scientific philosophers got rid of the notion of a lawmaker, they kept the notion of law, and that the idea that the world is a material machine run by law is a presumption just as unscientific as religious doctrines that affirm it is a material machine made and run by a lawmaker. Epistemology David Parkin compared the epistemological stance of science to that of divination. He suggested that, to the degree that divination is an epistemologically specific means of gaining insight into a given question, science itself can be considered a form of divination that is framed from a Western view of the nature of knowledge. Polymath and episcopos of Discordianism Robert Anton Wilson stresses that the instruments used in scientific investigation produce meaningful answers, relevant only to the instrument, and that there is no objective vantage point from which science could verify its findings since all findings are relative to begin with. The field of eco-phenomenology disregards science and technology on ontological grounds. and calls for an openness to the essential elements of human experience with the world. It wants to enter into the sensorial present, and to recover the moral sense of our humanity by recovering first the moral sense of nature, as an invocation to adopt a kind of deliberate naivety through which it is possible to encounter a world unencumbered with presuppositions. Eco-phenomenologists argue that the current environmental crisis is equally physical and metaphysical, and that a fundamental reconceptualization of human relationships with the natural earth is necessary to help undo the damage done by a culture that takes part in utilitarian exploitation of the natural world. It is because of this that eco-phenomenologists attempt to probe beneath Western understandings of philosophy, temporality, and teleology, as well as economic, social, and scientific evaluations of nature. Cognitive and publication biases within science. Most of the people who are against the mega-tsunami theory are never going to be convinced, no matter how much data I bring to the table. That is how it is in science. Dallas Abbott, geologist and author of Madagascar mega-tsunami study. While many scientists and skeptics point out cognitive biases that may permeate common sense thinking and cause illogical conclusions, the same biases are much less likely to be examined within the scientific community. Critics argue that the biggest bias within science is motivated reasoning, whereby scientists are more likely to accept evidence that supports their hypothesis and more likely to scrutinize findings that do not. Scientists do not practice pure induction, but instead often come into science with preconceived ideas and often will, unconsciously or consciously, interpret observations to support their own hypotheses through confirmation bias. For example, scientists may rerun trials when they do not support a hypothesis but use results from the first trial when they do support their hypothesis. It is often argued that while each individual has cognitive biases, these biases are corrected for when scientific evidence converges. However, systematic issues in the publication system of academic journals can often compound these biases. Issues like publication biases, where studies with non-significant results are less likely to be published, and selective outcome reporting bias, where only the significant outcomes out of a variety of outcomes are likely to be published, are common within academic literature. These biases have widespread implications, such as the distortion of meta-analyses where only studies that include positive results are likely to be included. Other issues include replication crisis, where journals are less likely to publish straight replication studies, so it may be difficult to disprove results. Statistical outcomes can be manipulated as well. For example, huge amounts of participants can be used and trials overpowered so that small difference cause significant effects, or inclusion criteria can be changed to include those are most likely to respond to a treatment. Whether produced on purpose or not, all of these issues need to be taken into consideration within scientific research, and peer-reviewed published evidence should not be assumed to be outside of the realm of bias and error. Some critics are now claiming that many results in scientific journals are false or exaggerated. Problem of reproducibility. I think we knew or suspected that the literature had problems of reproducibility, but to see it so clearly, on such a large scale, it's unprecedented. Jelta Wischertz, an associate professor in the Department of Methodology at Tilburg University, the behavioral science and social sciences have long suffered from the problem of their studies being largely not being reproducible. Now, biomedicine as well has come under similar pressures. Though science itself allows for flexibility and it has no effect on the scientific method, credibility of scientists themselves and their work reflects on public opinion of science as it's practiced. Ethics. Several academics have offered critiques concerning ethics in science. In Science and Ethics, for example, the professor of philosophy Bernard Rollin examines the relevance of ethics to science, and argues in favor of making education in ethics part and parcel of scientific training. Social science scholars, like anthropologists like Tim Ingold, and scholars from philosophy and the humanities, like Adorno in critical theory, have criticized modern science for subservience to economic and technological interests. A related criticism is the debate on positivism. While before the 19th century science was perceived to be in opposition to religion, in contemporary society, science is often defined as the antithesis of the humanities and the arts. Many recent thinkers, such as Carolyn Merchant, Theodore Adorno and E. F. Schumacher, considered that the 17th century scientific revolution shifted science from a focus on understanding nature, or wisdom, to a focus on manipulating nature, i.e., power, and that science's emphasis on manipulating nature leads it inevitably to manipulate people, as well. Science's focus on quantitative measures has led to critiques that it is unable to recognize important qualitative aspects of the world. Feminist critiques. Feminist scholars and female scientists such as Emily Martin, Evelyn Fox Keller, Ruth Hubbard, Londa Schiebinger and Bonnie Spanier have critiqued science because they believe it presents itself as objective and neutral while ignoring its inherent gender bias. They assert that gender bias exists in the language and practice of science, as well as in the expected appearance and social acceptance of who can be scientists within society. Sandra Harding says that the moral and political insights of the women's movement have inspired social scientists and biologists to raise critical questions about the ways traditional researchers have explained gender, sex and relations within and between the social and natural worlds, and Fausto Sterling is a prominent example of this kind of feminist work within biological science. Some feminists, such as Ruth Hubbard and Evelyn Fox Keller, criticized traditional scientific discourse as being historically biased towards a male perspective. A part of the feminist research agenda is the examination of the ways in which power inequities are created and or reinforced in scientific and academic institutions. Language in Science. Emily Martin examines the metaphors used in science to support her claim that science reinforces socially constructed ideas about gender rather than objective views of nature. In her study about the fertilization process, for example, she asserts that classic metaphors of the strong dominant sperm racing to an idle egg are products of gendered stereotyping rather than portraying an objective truth about human fertilization. The notion that women are passive and men are active are socially constructed attributes of gender which, according to Martin, scientists have projected onto the events of fertilization and so obscuring the fact that eggs do play an active role. Martin describes working with a team of sperm researchers at Johns Hopkins to illustrate how language in reproductive science adheres to social constructs of gender despite scientific evidence to the contrary. Even after having revealed the egg to be a chemically active sperm catcher, even after discussing the egg's role in tethering the sperm, the research team continued for another 3 years to describe the sperm's role as actively penetrating the egg. Media perspectives. The mass media face a number of pressures that can prevent them from accurately depicting competing scientific claims in terms of their credibility within the scientific community as a whole. Determining how much weight to give different sides in a scientific debate requires considerable expertise regarding the matter. Few journalists have real scientific knowledge, and even beat reporters who know a great deal about certain scientific issues may know little about other ones they are suddenly asked to cover. Politics. Many issues damage the relationship of science to the media and the use of science and scientific arguments by politicians. As a very broad generalization, many politicians seek certainties and facts whilst scientists typically offer probabilities and caveats. However, politicians' ability to be heard in the mass media frequently distorts the scientific understanding by the public. Examples in Britain include the controversy over the MMR inoculation, and the 1988 forced resignation of a government minister, Edwina Currie, for revealing the high probability that battery eggs were contaminated with salmonella. Some scientists and philosophers suggest that scientific theories are more or less shaped by the dominant political, economic, or cultural models of the time, even though the scientific community may claim to be exempt from social influences and historical conditions. For example, zoologist Peter Kropotkin thought that the Darwinian theory of evolution overstressed a painful, we must struggle to survive way of life, which he said was influenced by capitalism and the struggling lifestyles people lived within it. Karl Marx also thought that science was largely driven by and used as capital. Robert Anton Wilson, Stanley Aronowitz, and Paul Feyerabend all thought that the military-industrial complex, large corporations, and the grants that came from them had an immense influence over the research and even results of scientific experiments. Aronowitz even went as far as to say, it does not matter that the scientific community ritualistically denies its alliance with economic, industrial, and military power. The evidence is overwhelming that such is the case. Thus, every major power has a national science policy. The United States military appropriates billions each year for basic, as well as applied, research.